Alright guys, welcome back. We have another question from chapter 2 up here in Johnston textbook, and one of you guys asked me to solve this question. We have this rope AC and we know the tension in the rope is 365 Newton. We need to determine the resultant of the three forces exerted at point C of post BC. So basically at point D we have so let's call this point C. We have three different forces, the 500 ones. Top we have the 200 Newton here, and we have the tension which is 365 Newton. And we're gonna solve this question by breaking down each of these three forces into x and y components. And since we have the dimension and all the information, it should be pretty straightforward. And let's call this our x, and this will be our y. So we'll start with the first one, or the 500 Newton force. So looking at that, we'll see that Fx of the 500 Newton force is positive because this will be our x and this will be our y. So it is a positive moment, and it will be a positive force, so 500. And we have information about the dimension, so we have this right triangle over here, and Fx will be the cosine of this angle alpha here, which will be 24 divided by hypotenuse, which is 25. And this would give us 480 Newton force. And same for the Fy, we have a positive force, and this time we will have the sine of alpha, which is 7 divided by 25. This would give us 140 Newton. And that would be pretty much everything for the first one. Let's go to the 200 Newton force. So the Fx and Fy. So the Fx for the 200 will be this one, and this will be our Fy. So we know that Fx is positive and Fy is negative. So we have 200. If we call this angle beta, we have information about beta. So we call this one beta, which is this angle in this right triangle for 3, 5. And we'll have 200 times cosine of beta, which if we look at this right triangle, cosine of beta will be 4 divided by hypotenuse, which is 5. So this will be 160 Newton. And Fy, as I mentioned, we'll have this time sine of beta, which is 3 over 5. This will be minus, there's only one left, and that would be the tension in the cable. And I'm going to show it in a different color. So this will be the force for the x and y force for the 365 Newton force for the tension in the cable. So we'll have Fx and Fy. We'll see the Fx is negative and Fy is also negative too, because they are in the opposite direction of x and y. So we'll have 365, and we have to figure out the angle in here. And what we can do in here is that we have all the dimensions in the question, and if we call, so we are looking for this angle in here, and we pretty much have all the information. We have the length of the rope here, which is the hypotenuse. We know this side is 1100, this side is 960, and the hypotenuse is 1460. So let's go with let's call the angle this time maybe theta. So we'll have for the x component, we have the cosine of theta, or 960 divided by 1460. So 960 divided by 1460. If we calculate this, we'll get minus 240 Newton. And for the Fy, again, we'll have 365. This time we'll have sine of theta, which is 1100 divided by hypotenuse, which is 1460. And this would give us minus 275 Newton. And the last step, we have to find the x component of resultant, which is the sum of all forces in x direction. So we'll go with the x of each one, this one for 500, this one, and this one. So we'll have minus 240 plus 160 plus 480, and this will be 400 Newton. And we have the same thing for Ry. We have minus 275 for the tension, minus 120 for the 200 force, and we have 140 for the 500 Newton force. And that would give us minus 255. So now if you want find the resultant, we have square root of rx squared plus ry squared, and that's for 2D. And if you have 3D, we'll have the same thing. We only have one more component, which is the rz squared. So this will be 400 squared plus 255 squared. The negative sign will be cancelled out because the power is 2. And from here, all r will be 474.37. And so it's not over yet because we have to show the direction of r. So what we found for r at the end, we had a positive rx, which was 400, and we had a negative y component, which was minus 255. And if we want to report the angle here, this will be our r. We go with this one, let's call it theta. The tangent reverse of ry over rx would give us the theta, and from here theta will be the tangent reverse of ry is this one, 255. And just make sure that we don't need to apply the negative sign in here because we're considering just this right triangle here, and we don't need to be worried about the negative sign because we are already counting for the directions. So we just go with the positive or the absolute value of rx and ry, and from here we can find the theta 32.5 degrees. And if we want to show the r, we will have 474 Newton, and the angle will be what we found in the previous step, 32.5 degrees, and that would be the final answer for this question. And that would be it for this. Please make sure to subscribe to the channel and share this content with your friends that are taking the same course and they need some help with these problems. And you guys take care, and I'll see you in the next video.